Now, today's class, we are going to solve numericals based upon the laws of chemical combination. So, of course, we have a 3 laws of chemical combination. So, but class 9th, we'll study only 2. Third one, if it is time permits and we have sufficient time, we'll discuss. So, now let us come to the only 2 laws of chemical combination. So, first law is call it as, what is the first law, everybody? Law of conservation of, yes, please. Law of conservation of what, guys? Law of
Mass.
conservation of mass. Second one is call it as, what is the second one?
Law of
Law of
constant composition.
constant composition. Law of constant composition, or we can say
Law of definite proportion.
yes, definite proportion, or also we can say fixed proportion. That is what we used to call it as. Laws of chemical combination. So according to the law of conservation of mass, what is that actually? Mass neither be created nor be
Destroyed.
yeah, neither be created nor be destroyed. So that is what we used to say it is law of conservation of mass. So means mass of the reactants is equals to what, everybody?
Mass of the
Mass of
product.
the products. Before reaction, the mass of total reactants is equals to after reaction, mass of total products. So that is what we used to call it as, what we used to say, everybody? Law of conservation of
Conservation of mass.
no. Law of constant proportion means, as I said in yesterday's class, we have taken for example water. So by mass ratio, what is the mass ratio? I will teach you how to calculate mass ratio. So observe very carefully. So if you take the water, pure water anywhere in the world, pure water anywhere in the world, always the mass ratio will be always, what is that, everybody? Hydrogen is 1 and oxygen
1 is
is
8.
8.
yeah, 8. So this ratio will teach you. Don't worry about it. Just I am saying you. If I take another substance, another. If I take carbon dioxide, different. If I take ammonia, different. Like that. This ratio is always remains constant. So that is what we used to say law of constant proportion. So, for example, copper oxide. If you have taken copper oxide, CuO we will take. So if you take the copper oxide, the mass ratio is always 4:1. So let us, we'll discuss it. Don't worry about it. So you just remember that. That's what I'm saying. So these ratios are always remains constant. Mass ratio. Which ratio? Everybody? Mass.
Mass ratio.
That is what? Clear? All of you? Understand? So this mass ratio is always remains constant. That is what we used to call it as. Okay. What is to say, everybody? We used to say it as a law of constant composition or definite composition. Okay. I will say you, Laksha. That's what calculating I'll teach you. Why are you worrying? You just listen. That's all. Okay. And one more thing. I made a small mistake here. Copper oxide formula is Cu2O. Learn it. Okay. So copper oxide. Also we can say copper 1 oxide. Copper oxide or copper 1 oxide. Cu2O. Please. Is it okay, everybody? Copper 1 oxide. Yes. Roman number 1 bracket. That is what copper 1 oxide. Clear? Mari? Lingesh?
Yes, sir.
So that is what. Copper 2 oxide will be there. That is, that formula is CuO. Copper Roman number 2 oxide. This is formula is CuO. So please note it. Which is, we have to be very careful. Clear? which is the copper 1 oxide or copper 2 oxide. Okay, so now let us start. As I said, these ratios are remains. Of course, when you solve the numericals, you'll understand. So first question, write it. Question number 1. Prove the law of conservation of mass when the mass of BaCl2. Can you tell me what is a BaCl2? BaCl2. Yesterday's class.
Barium chloride.
Yes. So BaCl2 means what, guys? Barium chloride. Learn. Everybody has to learn. Barium chloride is 20.8 grams. Na2SO4. Anybody? Na2SO4. I taught you. You should know. Na2SO4.
Sodium sulfate.
Sodium sulfide.
Everybody has to know. Grams. BaSO4. Barium sulfate. 23 grams. 23.3 grams. And NaCl. So this is the example of law of conservation of mass. Am I right or wrong? Verified. NaCl, sodium chloride, 11.7 grams in a chemical equation. In a what equation, everybody? In a chemical equation. Now, you have to prove that law of conservation of mass is true. So what is the equation? Can you tell me? Which is the reactants? These two are the reactants and these two are the what? Everybody. Yes, please. Products. Understand it? So BaCl2. What is the physical state? I taught you yesterday. What is the physical state? Solid. Wow, super. So Na2SO4 aqueous state. So will gives you one insoluble solid will come. What is the insoluble solid? We have some name. Yesterday I taught you. Yes,
Precipitate.
precipitate and NaCl. So now here sodium is not balanced. Can you tell me how much it is not balanced? Here 2 and chlorine also here 2, but here only 1. So I have to put here what, everybody? Yes, please. 2. So this is the balanced equation. So now barium chloride 20.8 grams, sodium sulfate 14.2 grams. So mass of reactants. Can you tell me, everybody, what is the mass of reactants? Fastly. Mass of reactants means what? Mass of BaCl2. Yes, please. Mass of BaCl2 plus mass of sodium sulfate. So which is equals to 20.8 grams plus 14.2 grams, which is total equals to how much, Ra?
35 grams.
35 grams. That is what mass of reactants. Next, mass of products. Mass of products is equals to mass of barium sulfate plus mass of NaCl. Okay, so which is equals to 23.3 grams plus 11.7 grams. So what is the total, everybody?
34 grams. 35 grams.
35 grams. Understanding? So from this I can say mass of reactants is equals to what, Agalya? Mass of products. That's all. So it is hence what has been proved, everybody. Hence it proves what, everybody? Proves the which law? Law of you. Law of what, guys?
Conservation of mass.
That is clear. You have to remember. Balancing, remember. Once again, I'm teaching. You are, of course, you are a 9th class, but still I'm teaching. We are not supposed to have a right to change the formula. We people have only right to change the coefficient alone. Ellame understanding what I'm saying, everybody? We can change only the coefficient. We cannot change the formula. Do you understand, guys, what I'm saying? Please respond. So
Yes, sir.
chemical formula will never change. Chemical formula of a compound remains constant. We are having balancing equation. We are having right to change only coefficient alone. Coefficient means friend. Purima, ellame. Do you understand what I'm saying? Everybody? Yes?
Yes, sir.
So please do it. It's very, very important. Anybody having any doubt, you can ask me. Clear, Mr. Sam, Prudhi? I'm asking you. Darshan, you are with the two numbers, I think. What happened? Can you hear me, everybody?
Yes, sir.
Yes,
Great. So completed. Next question, right? Calculate the mass of carbon dioxide. Calculate the mass of carbon dioxide. Calculate the mass of carbon dioxide released in the reaction. Released in the reaction. Lingesh, can you hear me?
Yes, sir.
Yeah. Do it. Calculate the mass of carbon dioxide released in the reaction. Released in the reaction. Released in the reaction. Released in the reaction. Released in the reaction when 6.3 grams of sodium bicarbonate. 6.3 grams of sodium bicarbonate. 6.3 grams of which carbonate? Everybody? Sodium bicarbonate.
sir, what is the formula for sodium bicarbonate?
NaHCO3. NaHCO3. Sodium bicarbonate. Or we can say sodium hydrogen carbonate. What is to call, everyone? Sodium hydrogen carbonate. Both are same. Sodium hydrogen carbonate, or we can say sodium bicarbonate. Okay, wow, ellame. So formula is NaHCO3. Please remember. Network problem for Darshan. Darshan, you have network problem. Verified. Me, I am okay. Okay, guys. What is the question, everybody? Reaction when 6.3 grams of sodium bicarbonate is added to 15 grams of ethanoic acid. 15 grams of ethanoic acid. Ethanoic acid. Ethanoic acid also call it as acetic acid. Note it. Acetic acid. Formula is CH3COOH. Learn, do it, then only you can make it. Clear? Everybody? 15 grams of ethanoic acid solution and 18 grams of residue. 18 grams of residue left behind. Purima, 18 grams of
Residue.
Residue means like one of the solid waste left behind. Along with that, what came? Carbon dioxide came. That is only we have to find it. Am I right or wrong? Yes, please. All of you. So equation, I'll write it. Check it, everybody. So reactants, can you tell me reactants, everybody? What is the reactants? Sodium.
Bicarbonate.
Bicarbonate. How many grams? Kavya, Alfin? 6.3
6.3
grams.
grams.
Reacting with the acid. What is acid?
Ethanoic acid.
Ethanoic acid. Ethanoic acid also we can say acetic acid, which is equals to how many grams? 15 grams.
Gram.
You residue, that residue name I am saying you, sodium ethonate. 10th class you will get this equation. Sodium ethonate. Second chapter, acid, bases and salts. You will get this equation. How many grams you got it? How many grams you got it? 8 grams. 18 grams. Okay. Next. What is the gas we are getting? Carbon. Yes. Carbon dioxide. That is only we have to find it. Am I right or wrong? Let me take it as a x grams. Any problem? Anybody? Any problem for anybody? Clear? Respond, Ra. Which we don't know. I am assuming as a x. Any problem, Ra?
No, sir.
No. Right.
No, sir.
So mass of reactants. Gokul, tell me, Gokul, mass of reactants, which is equals to what? Mass of sodium carbonate, NaHCO3, sodium bicarbonate, sorry, NaHCO3 plus mass of ethanoic acid, CH3COOH, acidic acid or ethanoic acid, రెండు the same. சரியா தம்பி? எல்லாமே?
Yes, sir.
Yes, that is what. See, why I am making formula, it will become a habit for you from now onwards. That is the only intention. Okay. So there is no intention behind it. If you make it, future, you never face any problem. Formula become a habit. That is the reason I am writing every time formula. So 6.3 grams plus 15 grams. Sorry. Yeah. 15 grams, which is equals to how much, guys? Both
21.3 grams.
21.3 grams. Kavya, are you there? Mass of products. Next, mass of reactants. Mass of reactants, sorry, this is reactant, sorry. Next, mass of products. Mass of products is equals to what? Mass of sodium ethonate. That is only residue. So sodium ethonate, also we can say, okay, everybody, sodium acetate also. So let us take the formula. Clear? Sodium acetate or sodium ethonate, C2H3, you can take it a formula, CH3COONA. What is the formula? CH3COONA, sodium ethonate, plus we are going to get carbon dioxide, mass of carbon dioxide. So this one is how much, guys? 18 plus mass of carbon dioxide, x grams. We don't know. So which is mass of products. So according to the law of conservation of mass, what we know, people?
Mass of
Yes. Law of conservation of mass. Law of conservation of mass. Mass of reactants is equals to mass of products. So mass of reactants how much? Everybody? 21.3 grams. Mass of reactants how much? 18. X. Okay, now x is equals to 18 will come this side. 21.3 grams minus 18 grams, which is equals to how much, Ra? X equals to, please respond, 3.3 grams. So hence mass of carbon dioxide released, how many grams? Hence
3.3 grams.
yes, hence mass of carbon dioxide released is equals to 3.3 grams. Any problem for anybody, you can ask me. I hope you all understand. Anybody, you all can ask. Clear, guys? Yes. Understand, Abba?
Yes, sir.
So proceed. Any doubt you can ask me. Clear? See, this is both questions related to first law. That is what first law of chemical combination. That is what conservation of mass. Now, next question is most important one. Conservation of, that is what constant proportion or definite proportion or fixed proportion. Remember, this is the most important one for your future. So actually, this all will study under the stoichiometry. A chemistry, a branch of chemistry, we will say, okay, stoichiometry. So how you are writing from the problem, which is reactant and which is product. Now, given question clearly mentioned, calculate the mass of carbon dioxide released. Released means it is a product or reactant. Everybody? Yes, please. It is product. Am I right? Next, released in the reaction when 6.3 grams of sodium bicarbonate is added to 15 grams of ethanoic acid. So addition, we are adding so that they are reactants or products. Everybody?
Yeah.
Reactants, that is what. And residue is left behind, means it is a product. That is the way I am getting the products and reactants. Allow me understand, Nivedan? Yes, Mr. Darshan, Prithvi,
Yes,
any
sir.
doubt, please let me know. Are you clear, everybody? I hope
Yes, sir.
Yes,
Sam,
sir.
Yes, sir.
Princey, Niroshi. Next. So, next one. Verify the law of C. Now, I introduced in this both the questions, I introduced one more point for you people, which is sometimes important, sometimes not important. But let it be make it as a common practice. That is what writing the statement. Understanding? So sometimes a statement having a half mark, sometimes no mark. That's why make a common practice that every time write the statement. Purema, Mr. Pranav, what I'm saying. So that is what it is. Any doubt, anybody can ask me. So next, question number 3. Verify the law of constant proportion for an experiment in which 2.06 grams of copper forms 2.06 grams of copper forms 2.576 grams of copper oxide and
Yes, copper oxide, can we say it as a CO2O?
yeah, Cu2,
CO2O.
yeah, copper 1 oxide. Okay, Mari?
Yes.
Yeah, copper oxide. And in another experiment, and in another experiment, 7.344 grams of copper oxide reduced to form 5.876 grams of copper. See, first experiment, from copper to copper oxide we are getting. Second experiment, from copper oxide to copper is coming. Have you observed that, everybody? I'm asking you to read the question twice, then only we can proceed further. Do you understand, everybody? Please respond, all of you. So first experiment, we are getting copper to copper oxide. Second experiment, we are getting, what we are getting? Anybody? From copper oxide to copper we are getting. So you have to be very, very careful while you are reading the question itself and while you are solving the question itself. Any doubt, anybody can ask me. Are you clear, everyone? Yes, we have to prove it now. So, of course, we'll prove it. So, I will show you. So, shall we go with the question now? Answer, everybody? Yes, please.
Yes, sir.
Love you now. So, first of all, understand the question. Copper is giving you the copper oxide, means copper reacting with the what? Anybody can tell? Copper oxide means you all people knows.
Oxygen.
Oxygen.
O2.
Very good. Okay. So when copper reacting with the oxygen, then you will get it copper oxide. Okay. So according to the question, now I am saying you listen. Particularly in exam, they specified copper 1 oxide. Copper 1 oxide formula is Cu2O. If they specified copper 2 oxide, look into the screen, copper 2 oxide, then formula is CuO. Or simply they will say you copper oxide. Then also formula is CuO. Understand? Everybody? That is the reason I have taught you now. Clear, everyone? Please respond. All of you? Yeah.
So then the formula is CuO,
Yes.
sir.
You take it as a CuO always. Clear, Mari? Understand? So
Yes,
that
sir. In case of
first.
copper oxide and
Yes.
copper 2 oxide.
Yes, yes. That's why I want to say you. Now, copper is a solid, burning actually, heating. Heat means it will be reactive with oxygen. Oxygen is present where, guys? In air. Understanding? So it will give you the compound, call it as copper oxide. Copper oxide. So this copper oxide only we used to say what? Everybody. Copper 2 oxide. What we used to say? Everyone? Copper 2 oxide. So balancing, check it. Here 2 oxygens are there. Here only 1. So I'll multiply with the 2. Here coppers become 2. Here only copper 1. So here also I'll multiply with the 2. So this is the balanced equation. Any problem for anybody? You can ask me. Clear, everybody? Yes, please. All of you?
Yes,
Respond, Ra.
yes, sir.
Yes, sir.
So now, all of you read the question. What they're saying? Copper oxide. If I burn the copper, what is coming? Everybody. If I burn the copper, it will come copper oxide. So how much I burned? Anybody tell? How much I burned? Yes, 2.06 grams I burned. How much oxygen? I don't know. Let me take X grams. So that finally I got the product. How many grams? 2.57
sir.
grams. Purima, ellame understood? Clear,
Yes, sir.
everyone? That is what. So from this you can see, I want get it. This is mass of copper. This is mass of oxygen will gives us mass of copper oxide. Now I want mass of oxygen. So what is the formula? Anybody modify it and tell me? Mass of oxygen is equals to what will happen? Mass of copper oxide minus mass of copper. Will you all agree with me? Everybody? Agalya, Shivani. So mass of copper oxide is 2.576 minus mass of copper is 2.06. So which is equals to, what is the answer? 0.516 grams. So this is the mass of oxygen. Any doubt? Anybody can ask me. Okay, guys, please respond. Yes. What? No response. Are you clear?
Yes, sir.
Next. So now, ratio we have to find it. What ratio? Mass ratio. So let us take now, what is the mass ratio? So mass of copper is to mass of oxygen. Make it quick, everybody, and tell me. What is the mass of copper? Mass of copper, how much, Ra? 2 point? Respond. 2.06 divided by Mass of oxygen. Can you tell me what is the mass of oxygen? 0.516. Understanding? That is what. Okay, basically we want to write the ratio. So let me write the ratio it is now. Okay, now you can see how I will write the ratio. 2.06 is to, I'll write it as a 0.516. Any doubt, Nivedan, in this? Clear, Mr. Gokul? Now, both write it. I am dividing. I want to find the ratio correct. How much ratio? So it is not proper. So I will divide both with write a statement with 0.516. Your choice it is. Both I am dividing. So remains constant. So which will become what? 1. And this divide and tell me everybody how much it is. 0.26 divided by 0.516. Anybody? Sorry, 2.06 divided by 0.516. Answer please. 0.516. Make it quick and tell me. All of you. So you'll get an answer 3.99 is to 1. So 3.99 means rounding off to 4. So what is the ratio? Everybody? Copper and oxygen ratio. How much it is? Mass ratio. Please respond. All of you? 4 is to 1. That is what you have to remember. Okay, guys? Clear? Try it. Everybody do it. Yeah, 4 is to 1. Clear? Now, so what is the mass of copper and mass of oxygen ratio? Everybody? How much? 4 is to 1. In which? Yeah, this is experiment number 1. So EXP1, this is what we got it. Now EXP2. What is EXP2? Everybody? Experiment number 2, read it. A reverse reaction. What is a reverse reaction? All of you verify. All of you verify it. What is that? Another
CuO
experiment,
is equal to
7.344 grams of copper oxide reduced from 5.78 grams of copper, and then remaining what is there? Oxygen will be there. Am I right or wrong? Yes, please. Reverse reaction. So again, same thing. Mass of copper oxide is equals to mass of copper plus mass of oxygen. So mass of copper oxide, how much, Ra? 7.344, which is equals to mass of copper, how much? 5.876 plus mass of oxygen. So I want mass of oxygen. What will happen? 5.786 will come this side. So 7.344 minus 5.876. So what is the answer? Subtraction. I'm expecting from my students. Everybody is to say. Answer.
Sir, on doubt, sir.
Yes.
Sir, on doubt, sir.
Yes.
Why are you taking this equation again, sir? They are saying that copper oxide reduced to form.
Yes, Mari. Copper oxide reduced means, suppose if you want to form the copper oxide means you need copper and oxygen, then copper oxide
Sir,
will
that
give you,
means,
yes, it won't give you the oxygen. Do you understand what I'm saying? Clear?
yes,
If you want to form the copper oxide, you need copper and oxygen. Then if you take reverse reaction, again copper and oxygen will come. You understand? That
yes,
is
sir.
what. Okay. Then what is the answer? Lingesh answered. Very good, Lingesh. 1 point, everybody. 1.468 grams. That's all. So then, so mass of copper is to mass of oxygen. So we have to find it. So what is the ratio? 5.876 is to 1.468. So divide both with 1.468, 1.468, because you might be asked why, sir. We have to make it into simplest ratio. That is why. So this both will turn up into 1. Do this division and tell me, everybody. 5.786, 5.786, 5.786 divided by 1.468, which is equals to what again? Approximately equals to, verify it. Approximately equals to 4. So 4 is to 1. So what is the mass ratio, everybody? Mass ratio remains what? Please respond, all of you. Mass ratio remains what? Same, 4 is to 1. Understanding? So we can see from above calculations that the ratio of mass of copper and oxygen element is same in the two samples. Am I right, everybody? Both experiments remains constant or not? Everybody verify, please respond. So means, what does it mean, everybody? What is that value? 4:1. So it proves the which law? Law of, yes please, law of constant composition or fixed composition. That is what. I hope you all understand. Anybody having any doubt, you can ask me. Abhirami, Arasini, understand Arasini?
Sir, can you please go the last statement?
Yeah, I will make it. Any doubt, anybody can ask me. Clear, guys? So whatever the experiment, mass ratio is remains same. You may be get different amount of product, different amount of reactants or XYZ. But finally, mass ratio is remains what? Everybody? Mass ratio is
Constant.
remains constant. That is what. Alpin, do you understand Alpin how to solve? Abhirami?
Yes, sir.
Yeah, please. So
Yeah.
this is the most important one. Compared to law of conservation of mass, this is very important, and this based upon this questions will ask every time. So any doubt, anybody can ask me. So if not, you should try to solve your own. So always it is very important. Hasini Sudhakar, clear? Any doubt? Okay, so do it, everyone. Make it quick. Solve it. Understand, Princey? Are you there? I want to see.
Sir.
Yeah. Ma, simply sitting, nothing is going to work out. You have to solve. The more you solve,
Okay, sir.
more you can do.
Okay, sir.
Yeah. Unless you put the pen in your notebook, days will that days gone. Simply it's not easy at all, I'm saying. So days are very, very tough. You can see the competition also how much it is. So kindly work and make it. So finish it means then next class till here you solve it. I hope everybody understand, Mr. Sam, Mr. Sanjay. I'm expecting. So if you have been done this, then next class we are going to do. So with the help of these laws, Mr. Dalton proposed a theory. That is what we used to call it as a Dalton atomic theory. Yeah, Dalton's atomic theory. So what is this Dalton's atomic theory? What is the explanation of law